Here you're asked to evaluate this triple integral, but the bounds are not given. You have to figure out the bounds. And if you look at it, the bounds are given as spheres, so I think the natural coordinates to integrate this over should be the spherical coordinate system. So first, remember the spherical coordinate system's formulas, that rho is equal to square root of x squared plus y squared plus z squared. And really, I think for this one, you just need this, and that rho squared is x squared plus y squared plus z squared. If we had some other things to be written, if I had like x and y separately, then I might have to think about other additional formulas, but this would be enough. Okay, so now how do we write this down as a spherical coordinate system? Well, first remember that dv in spherical coordinate system is rho squared sine phi d rho d phi d theta. And this part right here is called the Jacobian, and that's needed for the spherical coordinate system. So anytime you go from rectangular dz dy dx and you want to go to spherical, you need this extra factor. So that's very important. And then now let's think about how one would paint this region where it's a sphere. So let's think about the sphere. You have a small sphere and a bigger sphere. They're both spheres like this. And having d rho inside means that you start from the origin and you start painting outwards. But over here you don't paint, you only paint this much, right? Which means the point where you start painting is from rho equals to 4, and you end at, not rho equals to 4, sorry, this is a radius 2 sphere, and this is radius 5 sphere, so it's rho equals to 2 until rho equals to 5. So the points on the outer sphere is 5 away from the origin, whereas points on the inner sphere is 2 away from the origin. So that means we integrate from 2 to 5. Okay, so that actually solves much of our problems, because see, we have e of minus rho squared over rho, because the denominator is rho, this is rho, and then you also have rho squared sine phi times d rho d phi d theta, and rho starts from 2 until 5. And then you just have to think about what phi would be. Phi starts from the North Pole, so this point will be phi equal to 0, but as you go further away, the angles increase. So at the equator, phi becomes 90 degrees, and then on the South Pole, which is the farthest point from the North Pole, that's 180 degrees. So phi starts from 0 until it covers pi. So phi starts from 0 and it covers until pi. Whereas theta goes all the way around, it's 360 degrees, 0 to 2 pi. Okay, so this integral here is equal to this. Now, you could represent this using the rectangular coordinate system, but if you do, then you'll find that the integral itself is so hard, you will naturally require some transformation, which will bring you down to the spherical. So you eventually have to do this, okay? Alright, so let's simplify this. One of the rho will cancel with one of the rows here, so rho and rho. And then I see that you can do u equals to negative rho squared to do u substitution, and therefore du would be negative 2 rho d rho, and that means d rho is equal to negative 1 over 2 rho du. Another thing is when rho is 2, u is negative 2 squared, which is negative 4. And then when rho is 5, u would be negative 5 squared, which is negative 25. So this is equal to 0 to 2 pi, 0 to pi, and then the u value would be from negative 4 to negative 25, e to the u, and there's a rho which I don't know what to do, sine phi. This rho went away, so I'm only rewriting negative rho squared as u. But then d rho is negative 1 over 2 rho du, d phi d theta. And rho now cancels. And there's a minus 1/2, which can be brought outside. So let's just bring it outside and continue the integral. You have e to the u integrates to e to the u. So it's just e to the u. Sine phi is just a constant multiple. Remember, we're doing partial integration, which means when you're integrating by u, phi is considered as a constant. So it's just this. And then u value, you have to plug in negative 25 and also negative 4. D phi d theta. Okay, so let's continue. That means we have to plug in negative 25 and negative 4. Let me copy that last integral over here so we can continue. Copy. Okay, bring it over here. Okay, then this would be negative 1/2, 0 to 2 pi, 0 to pi. Negative 25 goes into u, sine phi, and then subtract negative 4 goes into u, sine phi, and you still have to integrate by phi and integrate by theta. I think since sine phi is the common factor, let's factor that out and see what we get. So you have e to the negative 25 minus e to the negative 4 times sine phi d phi d theta. And although this looks scary, it's just a constant multiple, so if you integrate sine phi, you just get negative cosine, right? So let's do this. You get negative cosine can be, negative value can be brought outside. So you get positive 1/2 integral from 0 to 2 pi, 0 to pi. No, we already integrated phi, so it becomes e to the negative 25 minus e to the negative 4 cosine phi, and to phi you have to plug in pi and then 0. And when you plug in pi into cosine pi is negative 1. Actually, this is just another constant, so let's also bring that outside. So you have 1/2 e to the negative 25 minus e to the negative 4. And then if you plug in pi in the cosine, it's negative 1. If you plug in 0 into cosine, that's 1, but you have to subtract. And then that's negative 2. And integrating negative 2 gives you negative 2 theta, right? So you have 1/2 e to the negative 25 minus e to the negative 4 times negative 2 theta, and into theta you have to plug in 2 pi and 0. 2 and 2 cancels, and when you plug in 2 pi, that's just 2 pi. When you plug in 0, that's nothing. So you end up with e to the negative 25 minus e to the negative 4 times negative 2 pi. So that's the answer. And you might be wondering that this is a positive function and you're integrating over some domain, so the value should be positive, and you see a negative. But if you think about it, this value is smaller than that one, so the actual integral is still positive. Or you can multiply negative over here and say this is 2 pi times e to the negative 4 minus e to the negative 25. That would be the answer.